This is from the Gateways book, student pages 70. And this would be a great place for you to reinforce or to teach and introduce, if you haven't done so already, independent and dependent variables, how you change one variable in an experiment. But first of all, your Engage has you determine which of the two boxes will feel heavier when they're lifted. But the rules are you cannot lift the box, either one of them, and you may not look inside the box. So students' job is to figure that out, and hopefully they will come up with it that you could push. We didn't tell them they couldn't push, we just told them they couldn't lift. But you could push and you could tell which one has the most mass. Now they are going to design a plan, and they are going to determine how force affects the length of a rubber band. So by adding weights to the rubber band, they're adding force to the rubber band. By using a ruler or a meter stick, it's possible to measure change in the length of the rubber band the more force is added. So first they need to place the rubber band on some sort of apparatus. They would measure the length, and you'd have to have someone stretch that down and push it. They could measure that and record it. Then they would add their masses. And you can start with large mass, and you don't have to have masses as like I have. You can have just objects. So this one stretches all the way down, so then they would measure the length. It's a bit too much for that rubber band. And then you could have them just try the different masses and see the force. And then they'll take their meter stick or their ruler, and they would measure how far it's stretched and record that. And then continue with the conclusions. They're going to write a statement that describes how adding force affects its length, and use it as appropriate. And then you continue with the rest of the experiment. Let's explain and elaborate. They get to measure forces. They're going to use a spring scale, and it just goes more into an explanation, and then you have your Engage. A very good lab activity to do from Gateways student pages 70 through 74. For the velocity station, you need a calculator, a stopwatch, and 5 meters of tape. And what you'll do is you'll tape 5 meters, go ahead and pre-mark it on the floor. We're going to use this seam and the carpet right now as my demo. And then you're going to have the students take a stopwatch, and they're going to time how fast they can walk the length of the string or the floor without lifting their feet from the floor. And then they're going to repeat it 5 times, and they'll just calculate. So they'll have to just scooch across the floor. They're going to record that, and they're calculating speed. Now your paper says velocity, and the only difference is that velocity has direction. So if they're adding velocity on their paper, make sure they put a direction: north, south, east, west, left, right, front, backwards. And also I found a discrepancy here. It says string where it should say tape. So just whatever you put down, have the students use that. Now the inertia station says that we need to have a physics cart, a triple beam balance, a spring scale, and fishing weights. Now we're going to do a makeshift here and use, I'm going to use just this container top, just to show you that you can use different things. You don't have to have exactly what's on there. So we're going to use this container top, and first off they ask you to you find the mass of the top, and you record that on your paper, and then you're going to measure the force it takes to move it across the table. Now I'm going to use the floor because the floor has carpet, and it's going to give me I have a little bit better tension, so I can get more resistance. So you'll measure the force it takes to scoot it across the floor. Now you're going to add some masses. So you would record, you'd put the mass on the triple beam balance, you're going to mass it, then you're going to write that down on their paper. Then they would add the mass, one mass, and pull, and then they're going to record in newtons. Then they'll do the second, they'll add the mass of a second, weight, pull, and record in newtons. Then you could do a third. All you're trying to do, they're just going to keep adding it so they'll know the total mass. They'll have to make sure they add the 3 different masses plus the container, or whatever you decide to use. You can use a physics cart, you can use a basket, just anything that the students can put some weight on it, and then just pull it across the floor will work for this experiment or station. This is the friction station. You need a spring scale, aluminum foil, wood block, plastic wrap, wax paper, and sandpaper. Now first you're going to have the students take the spring scale, and they are going to lift the block, and they're going to measure the the force, in newtons, how much force it takes to lift the wood block off the table. Then they're going to take the wood block and we're going to pull it across the table and see how much force is required to pull the block across the table. Now you might want to find something that's pretty heavy, or rub it across the carpet just to get yourself a little bit of tension there. Then they're going to take each of the following materials: the wax paper, the aluminum foil, the wax paper, and the, let's say, plastic wrap and sandpaper, and they'll put the block on it, and then they'll pull. The more mass you have on the block, the better this is going to be, because you're not getting a whole lot of friction right now. But we'll pull with the plastic wrap, and they'll record the force needed. Then they will do the same thing. They'll repeat it with the aluminum foil. And record. Then they'll use the wax paper and the sandpaper. I'll do the sandpaper right now. So it would be better if you have a block or an object with a lot more mass to lift, so that when you pull on your spring scale, you'll have a bigger difference on your force, so the students can read it more easily. This is the acceleration and mass station, where you have 2 meter sticks and a wooden block, and the students will set this up with 2 meter sticks, a wooden block, and space them about 1 centimeter apart, or as big as your marble is. Put the plastic cup at the end and cut a notch like a tunnel. You'll have that set up for them. And you put that in. Then you'll place the marble on the ramp, and they're going to measure how far the cup moves. So then they'll take their meter stick or their ruler, and they'll measure and record how far the cup moves. Next, you'll add some weight or some masses and tape this down to the cup. They'll replace the marble ball, they'll roll it, and then they're going to measure and see how far the cup moves from that point. And you can do this several times. You can use pennies or you can use washers, whatever you want to do, but have them do one at a time. This is the action-reaction station. You need a ruler and some marbles. It suggests 10. So what they do is they put 4 marbles in the middle of a ruler with the groove, and then with the other marble at the end, make sure you're on a level surface, by the way, they're going to gently push the marble and watch and see what happens and record. Then they can experiment and try it with 2 or more marbles and see what happens and record their observations. This is the measuring force motion station, number 5. For it, you need a spring scale and either a set of weights, masses, or some type of objects the students can measure. Now what they want to notice is that on the spring scale, it's measured in one side on grams, and on the other side it's measured in newtons. And so your instructions are for the students to use the spring scale to lift a mass and record in newtons. And then they're also supposed to record in grams. And then they're going to compare this later on. So you have them record in newtons and in grams. Then they will lift another weight or a mass and then try this again. Measuring newtons, measuring grams, and recording it and answering the questions. You can use any objects. You don't have to use masses. Just tie a string around them if you don't have the masses.